The last topic of the unit is going to be comparing equations to graphs and vice versa, making sure that we understand the difference between roots and end behavior and how to figure out which equation and graph would match up. So we need to have a basic idea of what the graphs are going to look like kind of overall. So that if we look at a graph, we know some really, really basic things about it. And then we can use the rest of the things that we're going to talk about to kind of piece together the rest of the equation. So one of the things we want to make sure that we know kind of immediately is what the graph should look like. And that really comes down to what it does at the ends, the end behavior of the graph. So what direction does it go in the right and what direction does it go to the left? All of these graphs are either going to continue going up to infinity forever, or they're going to continue going down to infinity forever, depending on what their degree is and what their leading coefficient is. So if we take a look at this little chart here, which is a decent thing to be able to take a look at to understand what's going on. So if I have even degree, right, remember that degree is the highest exponent. And obviously even numbers, I think we know what those are, and odd numbers. All right, so even degrees are going to both point in the same direction. So they're either going to both go up, like in this graph right here. So they're both going to point up, they're U's, or they're both going to point down. Now they could have extra turns in there. So an even could look like this. But the key is that the tails, the ends, have to point in the exact same direction for it to be even. Odd degreed equations have one that points one direction and one that points the other. So one's going to point up and one's going to point down. So if you look at these graphs, you've got this one where the one on the left points down, the one on the right points up. And the other graph here is the opposite. One points up and one points down, but in the opposite direction. They can have other turns in them, but the key is that they have to end up pointing in the opposite direction. So that would be another example of an odd graph. So they can turn multiple times, but at the very, very end, they have to always point in opposite directions. All right, so that's the first part. The second part is the leading coefficient, and that means the number in front of the first term, or we have to be careful here. I'm going to write the highest exponent term. All right, so that's what a leading coefficient is, the number in front of the highest exponent term. So if it's positive, it's the standard equation. For even, they both point up. All right, so even they point up both ends. For not even, sorry, used the wrong word. For negative and positive, this is what we're looking at. So for positive, they both point up. For negative, they both point down. For, sorry, negative, they both point down. For odd, it's going to kind of increase. So it's going to start pointing down and then end pointing up for positive. So it's down on the left-hand side and up on the right-hand side. And then for the other one, it's going to be up and then down. And I guess what I would say is probably the easiest thing to do is just know what the even positive ones look like. Even and odd positive ones look like, and then the odds are just flipped over. So that when you look at one of these, you can just kind of draw a little sketch on the side of, okay, it should look kind of like this, and then you can piece the rest of it together with whatever else is asking you. So that's kind of the initial thing. It sounds much, much more complicated than it is. So as you go down through and practice a few of these, kind of look at what the initial steps that I'm doing to get what the graph should look like started.